So as I mentioned, not every equation we go to graph is going to be in our simple y equals form. Here, these two equations are in what we'd call standard form. We have to do a lot of work to get them into the graphing form, that slope-intercept form. Let's start with this top equation. I'm just going to slide it over here. 2x plus 3y equals 18. To get that in our graphing form, we have to get y by itself. So we will start by subtracting 2x. So we have 3y equals 18 minus 2x. And then we'll divide by the 3. The 3's cancel out. Y equals 18 divided by 3 is 6. Negative 2x divided by 3 is a negative 2/3 x. So we graph that. We start out at 1, 2, 3, 4, 5, 6. That's our first point. From there we go down to, we run 1, 2, 3. Gives us a point. Now let's do it one more time. Down to, run 1, 2, 3. Get a second point. And we know our line goes through those points. For our second equation here, we know that we need to get y by itself again, so we're going to subtract x. Gives us negative 2y equals 2 minus x. Now remember, we think of this as a 1x when we divide here. We're going to divide by negative 2. We get y equals 2 divided by negative 2 is a negative 1. Negative 1x divided by negative 2. Well, negative divided by negative is a positive. 1 divided by 2 is just 1 over 2, and then we put the x on there. So there we start out at a negative 1. That's our first point. And then we rise 1, run 2. Get our second point. Let's do it again. Rise 1, run 2. One more time. Rise 1, run 2. And there we go. And we see there that both of those lines go through the point 6, 2. They intersect at 6, 2. So I'm going to have you guys try one here. Let's have you do 2x minus 4y equals negative 4. And x plus 3y. Actually, let's do x plus 2y equals 14. Graph those two equations and see if you can find the solution to that system. Okay, so let's take a peek here. The top one, we'll rewrite it here, is 2x minus 4y equals negative 4. We solve that for y, we're going to subtract 2x. Negative 4y equals 4 minus 2x. And we'll divide by negative 4. So negative 4y divided by negative 4 is just y. 4, oops, that should be a negative 4 there. Sorry, I dropped my negative accidentally. That was a negative 4. Negative 4 divided by negative 4 is a positive 1. Negative 2x divided by negative 4 is a positive 1/2 x. So we start at positive 1, and we go up 1, run 2. Let's do it one more time at least. Up 1, run 2. And we know our line goes through those points. Our second equation here, we're going to subtract x from both sides. So 2y equals 14 minus x. And we'll divide by 2. So 2y divided by 2, the 2's cancel out, we just have y. 14 divided by 2 is 7. We treat this as a negative 1x divided by 2 is a negative 1/2 x. So here we're going to start out at 7. 1, 2, 3, 4, 5, 6, 7. Up here is 7. And from there we go down 1. Run 2. We'll do it again. Down 1. Run 2. I'll keep going. Down 1. Run 2. And we get a point out there. What does that appear to be? Looks like 6, 4. Appears to be where they cross. Let's make sure those work. And it does. It appears that works in both equations. So when we get that point, if we're doing this by graphing, what we really should do is test it in both equations. I can either use the ones I solved here, or I can go back to the originals. Probably more safer to go back to the originals, just in case we made a mistake solving one of these equations. So 2x minus 4y equals negative 4 is our first equation. X plus 2y equals 14 is our second equation. Let's try that 6, 4 in both of them. So 6 goes in for the x, 4 for y. And let's make sure that equals negative 4. So this is 12 minus 16, and that does equal negative 4. So the first equation works. Second one here, we put 6 in for x and 4 for y. 2 times 4 is 8. 6 plus 8 is 14. So we get 14 on both sides on that one. So that point does work in both equations. Now, as you can see, graphing, not the most precise way of doing things. we mentioned that if we have really large solutions or fraction or decimal solutions, graphing is really a poor way of doing it. So let's take a look at one here that's pretty straightforward. We're going to y equals 2/3 x plus 1. And y, or negative 2/3 x plus 1, I should say. And y equals 1/2 x let's do minus 6. So when we go to graph this top one will start out at a positive 1, and we'll go down to run 1, 2, 3. Let's do it one more time. Down to run 1, 2, 3. And put our point there. So we have our line going through those points. Second equation starts out at a negative 6. So 1, 2, 3, 4, 5, 6. There's our first point. It's a rise 1, run 2. We'll rise again, run 2. Once more, rise 1, run 2. And there we hit. So there's the solutions for that equation. And of course, we can see they cross here at 6, negative 3, it appears to be. So that is the solution to that system. And I can double check it in both equations, and it does work. But I had to be very, very careful laying out my slope. If you had grid paper, it would help. But it's still really kind of a pain to solve a system by graphing. So there are algebraic ways of solving them. One of the algebraic methods of solving it is called substitution. What substitution involves is looking at these equations and realizing that at the solution to this system, this x and this x are going to be the same value. In this case, they were both negative 3. And this y and this y are going to be the same value. In this case, they were both 6. So I can use that to combine my two equations. If I use the idea that this y and this y are the same value, if those y's are equal, well, this y equals negative 2/3 x plus 1, and this y equals 1/2 x minus 6. If the two y's are equal, those two equations have to be equal. Basically, what we did was we substituted, we took this and replaced the y in this equation with that negative 2/3 x plus 1 to make it one equation now with one variable. And the algebraic methods of solving a system of equations, if a system of equations has two equations, it's going to have two variables, it's going to have two equations. All the algebraic methods take those two variables and two equations, and they combine the two equations somehow to get one equation with one variable. That's kind of the point of our algebraic methods. When we get to three equations with three variables, our first step is going to be to combine them to get two equations with two variables, and then combine those to get one equation with one variable, to reduce it down to a single equation with a single variable. Now, there's still a lot to do to solve this because there's still a variable x on both sides, so I have to get rid of one of them. Now, negative 2/3 is the smaller one, so I'm going to get rid of that by adding 2/3 x. That makes that go away. So on the left side here, I still have 1. 1/2 plus 2/3 is 1 1/6 x minus 6. And now I'll solve that equation by adding 6. Both sides, I get 7 equals 1 1/6 x. And if I divide here by 1 1/6, 7 divided by 1 1/6 is actually just 6. I get x equals 6. So my algebraic method here, my substitution, allowed me to solve for x equals 6. Now, I combined a lot of fractions here without writing them off to the side. You can either use your fraction calculator to combine them, or you can do that combination off to the side somewhere, 2/3 plus 1/2. Of course, my common denominator is going to be 6. That'll work. Oh, come on now. Let's just try this again here. So 1/2 plus 2/3. Common denominator will be 6. 2 times 3, so 1 times 3. 3 times 2, so 2 times 2. 3 plus 4 is 7/6. That's where I got the 1 1/6. So then it was 7 divided by 1 1/6, or 7 divided by 7/6. So that was 7 over 1 times 6 over 7. 7's cross-canceled to give us the 6 over 1. So all that fractional work you can do off to the side, or you can use the graphing calculator to make it easier for you. But we still got x equals 6, which is what we had up here graphing. But we're sure of it now because we used the algebraic methods. We're not just trying to pull that off the graph. Now, that's just the x value. We still need to find the y value. I can use either one of my original equations. I'm going to use this one here, the bottom one, because everything's positive there. Y equals 1/2 x plus 6. Minus 6, sorry. That would make a big difference. So if I put that x equals 6 in there for x, y equals 1/2 times, instead of x, I'm going to put in 6. 1/2 times 6 is 3, so y equals 3 minus 6. 3 minus 6 is a -3, so y equals -3. So x equals 6, y equals -3 gives us that coordinate of 6, -3 is our solution, which is exactly what we found up above. We will look more at substitution and algebraic methods of solving equations tomorrow. For now, I didn't give you any homework time in the first hour, and I want to give you some time to work on that quiz as well. So I'm going to give you the last 28 minutes here as your homework time and quiz time for both hours. So your homework here out of the big book, you're going to be looking at page 475 through 476, exercise 17-1, 1 through 23, the odd. Solving systems of equations with graphs. Again, be very careful with them. If you have grid paper, use it. Okay, I'm going to shut down the recording here. If you want to work on that, I'll be on the network here for a while to answer questions. Otherwise, if you